So we'll go ahead and begin class for today. Just to make sure and confirm, everyone can see my screen, right? Okay, perfect. Just wanted to double check that, make sure everything is going well. And I don't know what's going on with this thing. Give me 1 second here. Okay, we should be okay. Okay, yeah, we should be fine. All right, so today about general research questions and designs. So one of the things that we'll be discussing today is how it is that we actually generate research questions for research projects, and then how it is that we actually design experiments as well. Because one of the most important things that we need to consider in terms of the whole idea associated with research is how do I even come up with the research question? So I made this a task for you guys for last week, and everyone submitted their initial research ideas. And a lot of your research ideas are actually very, very good. And I'm still working on the refining process at this point, and I'll have everything submitted back for you all by no later than on Thursday, whenever I give you back your feedback in terms of your research ideas. So as one of the things that you all probably noticed, that in terms of this whole idea of coming up with research questions, the idea of coming up with a research question is not necessarily that simple. It's actually quite a difficult process. Would you all agree? Yes, absolutely. It's a very difficult process. So when you think about what a researcher does on a daily, on a day in and day out basis, this is exactly what it is that we're doing. That we're coming up with research questions that we want to try to study in an experimental fashion. Yet it's not always that simple for us to be able to come up with this question. And many times we find that there are obstacles that get in our way to the identification of a research question. And those were some of the things that I talked about in last week's session in terms of our live session and also our online video, that coming up with research questions is actually a really hard thing. And a lot of it is really based on the way that we've actually gained knowledge. And remember, we gain knowledge through the idea of having experts in our field tell us about information and knowledge. We also gain information through tradition, or we also gain information just through the aspects of intuition. And the idea is that we gain these questions and we gain knowledge, and we want to explore new questions related to that specific knowledge that we already have. So when we think about the research questions that we designed for the purposes of our research questions for this last week, one of the things that we did is we probably based ourselves on information that we already know, and the way that we want to investigate something that we already know some information about, but we still have lingering questions about that same content. So the idea of coming up with the research question is much more than just, hey, whatever happened about the effects of the evil eye on motivation? Let's say, for instance, that may be a question that you may have, but again, we have to consider the multiple aspects associated with our topics of conversation, because there's certain things that we can explore and other things that we can't. So whenever it is that we're coming up with the idea of generating research questions really lead us to the identification of research hypotheses. So whenever it is that we talk about a hypothesis is going to be a prediction that's based on empirical evidence. So in other words, what we do is we look at all the previous evidence suggested associated with a specific topic, and then from that evidence, we now make a prediction about what's going to be happening in the future. So this is why I told you all last week in class, a hypothesis is not an educated guess. Because an educated guess would mean I really kind of don't know what's going to happen, but let's just kind of see what's going to happen. That's not really what we're about in science and in research. But rather what we try to do is we try to make a prediction based on all the other behaviors that have existed in the past. It's, for example, let's say a cheater. A cheater is always going to be a cheater. And why are they always going to be a cheater? Because they've demonstrated that pattern of behavior before, and we use that as evidence to suggest what's going to be happening in the future, right? So here, one of the things that we're always doing with this idea of research is we do the exact same thing. We already know that tons of people have already done research in specific topics that we're interested in. So for instance, let's say that you're interested in the effects of motivation for the differences across introverts versus extroverts. So is there any differences between introverts and extroverts on motivation? Let's say, for instance. There's lots of evidence that's already been collected by other researchers who've been doing research on the issues related to personality, on the issues related to motivation, and using all of their research, we can now come up with a prediction about our own research project, even though nobody's ever done anything related to our specific project, but at least people have done research projects that have been related to the other ideas associated with motivation and the ideas related to personality. So based on their findings, we can now make an empirical prediction about what's going to be happening in the future based on their specific evidence. Okay? And that's a very, very important thing. So whenever it is that we're coming up with the hypothesis, a hypothesis can actually be stated in two different ways. Now, whenever it is that we come up with the statements associated with the hypothesis, don't feel that the way that you're creating your hypothesis is any less valuable than the way that somebody else is creating their hypothesis. All hypothesis statements are very important because we're talking about what we expect to happen in the future. But there's two specific ways that we can actually state hypotheses. The first way is through what we call the construct form. So if you guys remember on Tuesday, I specifically talked about this idea of a construct. Now remind me really quick, what's a construct? Define it for me. Okay, so this abstract idea of what we're interested in exploring or we're interested in investigating. So when we think about this idea of a construct, things like aggression, motivation, introvert, extrovert, depression, anxiety, those are all constructs. Even though we all understand what we mean by that specific construct, we yet don't really know what that construct means. That's why we have to create an operational definition to define what my construct is. So one of the ways that we can actually state a hypothesis is through our construct form. So for instance, we can have something like the following: success will improve self-esteem. Now, whenever it is that we read this statement, right, this prediction that we're making about the future, success will improve self-esteem, what could success potentially mean here in our hypothesis if you guys had to make an idea or a suggestion associated with what success is? Okay, so potentially reaching a goal, whatever that goal may be. What else? Okay, so potentially a specific income. So once I reach, making $100,000 a year, I will claim myself to be successful. Okay, what else? Perfect. So you can make $1 million, but your GPA is a 2.0. You're not successful according to your definition, right? So here, one of the things that we have to understand is that this term, success, for us is a construct. It's an abstract idea of what we're working with. So when we think about the aspect of improve, what does improve mean for us in this hypothesis? Okay, so potentially here we see now higher scores, correct? That's what we may be talking about here, that we're seeing higher scores. So now when we talk about self-esteem, what's self-esteem? The self-perception of yourself, right, in terms of who you are and how you feel, okay? And here, all of these terms are very abstract in their nature. So what do we have to do? We can keep our definition of our hypothesis or our statement of our hypothesis as is. But yet one of the things that's going to happen is people are going to have a lot of questions. People are going to be a little bit confused as to what it is that you actually mean with this specific hypothesis. So rather, what do? We can state our hypothesis in an operational definition form. Now, what do we mean by the operational definition? We specifically state what each one of these terms is going to represent. So what does success mean? What does improve mean? What does self-esteem mean in this particular case? So here we can still state the exact same hypothesis of success will improve self-esteem, but now in more specific detail. So we can ask something like the following: receiving a grade of an A on an essay test will significantly increase scores on the performance subscale of the Heatherton and Polvey state self-esteem scale from pre-test to post-test. So now, whenever it is that you read this specific hypothesis, there's no way for you to misinterpret what you mean by success, what you mean by improve, and what you mean by self-esteem. Does that make sense? Perfect. Now, here's a question. Now, let's say, for instance, your grading scale goes from an F to an A plus. Here it says receiving a grade of an A on an essay test. What happens if you receive an A minus on the essay test? Have you been successful? Technically, no. Why not? Because it's lower than an A. Now, what happens in the case if you get an A plus? Are you successful? Yes? Are you guys sure? Okay. But here, for instance, you've said you have to get an A, not an A or greater. Does everyone see that? Now, for instance, you're probably going like, okay, come on. Now, that's just ridiculous. We all know that if you get an A plus, come on, you'd totally be more successful than if you just got a regular A. And I agree with you. But that's unfortunately the way that research works. If you didn't tell me that that's what I could get and I would still technically be successful, then technically I'm not successful. Everyone with me so far? So here, what should our definition actually reflect? It should say receiving a grade of an A or greater on an essay test will significantly increase those scores. Now here, for instance, we also see what improve now would mean for us in terms of our operational definition. What does improve refer to? The aspects of self-esteem, that your scores are going to go up, they're going to increase from pre-test to post-test. So now we don't have any concern about what the term improve means for us. Is everyone clear? Perfect. And last, now we also know what self-esteem refers to here. Self-esteem means your scores that you get on the Heatherton and Polvey subscale for the self-esteem. Okay? If you do any other self-esteem assessment that's not the Heatherton and Polvey state self-esteem scale, you don't have self-esteem according to our research question and our research hypothesis. It has to be this one. Everyone clear? Now again, this may almost seem like, oh, come on, now you're really just being, really nitpicky about everything. But unfortunately, that's really how we do research every single day, that we have to be very, very clear. Because if we leave it up to your imagination, we may then make potential inferences about what we assume should be behavior. Since we were talking about success will improve self-esteem. So here, when we talk about, for instance, depression, let's say that you being successful will improve depression symptoms. How do we actually define improve in that particular case? Does that mean that your scores would go up or should they go down? You should have less symptoms, exactly correct. So your scores should go down in this particular case. So here it should improve the symptoms that we're actually feeling. So in other words, we should have less symptoms. So here there seems to be that aspect that we always need clarification of information. Any questions, any concerns at this point? So of the two, which one do you think that we would generally want to use whenever it is that we're stating research hypotheses? The construct form or the operational definition form? Absolutely. The second method is always going to be the preferred method for our statements of our research hypothesis. And again, why? Because it leaves us with a very clear statement as to what it is that we're doing with our research hypothesis. We're specifically saying that these are the things that we're interested in, and this is how we're going to be measuring them. Very, very important. Now, even some of you already in your research questions and your research ideas that you posed to me initially for your projects, you already started talking about some of these particular issues. Some of you have already started to mention some of the questionnaires or some of the designs that you would want to use, or how you would collect the data, or where you would collect the data. Those are all part of the operational definition form of our hypothesis at a later point. Now, just to make sure that we all understand the clear difference between a research question and a research hypothesis, let's go through a couple of these. Now, let's look at this example here. Will there be a difference between men and women on their belief that the family is a critical component to a successful life? What do you guys think? Research question or hypothesis? Research question. What gives it away that it's a research question? The question mark, exactly right. It's got a question mark at the end. It's a research question. So here you'll notice that there is no specific prediction being made, either in construct form or in operational definition form. We're not saying that this is what we expect to happen. All there is we're asking this specific question about, well, what will happen, or will there be any differences? Now, number 2, men will have lower agreement scores compared to women on their belief regarding the family as being a critical component to a successful life. Question or hypothesis? Absolutely. It's a research hypothesis in this particular case. How do we know that? It ends in a period. It's making a statement of what we think is going to be happening in the future. A research question is only going to be posing for you a question regarding the construct of interest. That's it. It's always going to end in a question mark. It's never going to be a statement. So rather here, with a research hypothesis, it can either predict that differences may exist or that no differences may exist between our groups. And it's very, very important that we understand that whenever it is that we talk about a hypothesis could potentially predict that differences will exist or that no differences will exist. Those are the two options that we have for a hypothesis. Either differences exist or they don't exist, or there may be a relationship or there may be no relationship. Those are the options that we have. Questions up to now? Everyone good? Remember, I can't see you guys. So if you guys nod, I can't see you. Perfect. Thank you guys. Thank you. All right. So when we think of our hypothesis, hypotheses come in different forms. Now, generally, whenever it was that you were introduced to the idea of a hypothesis, you probably were in about 5th or 6th grade when you started learning about science. You were probably going to have a science fair project due somewhere around there, and you started talking about a hypothesis and how to develop a hypothesis and where hypotheses come from. So remember, our hypotheses come from the previous evidence. So in other words, back in the day when we were in 5th or 6th grade and we were working on our science fair projects, they probably asked us to go to an encyclopedia or to go on the internet or go to the library and find information or books related to our specific topic, read a little bit about them, and then try to make a prediction for the future. So in other words, again, going back to the previous evidence and now using that evidence to make a prediction. But then you also encountered, probably in a statistics course or in some other research-based course, where they introduced different types of hypotheses for you. So one of the ways that I always like to think of a hypothesis is that there's 3 different types of hypotheses that exist. The first one is what we call our null hypothesis. This is a statistical hypothesis. Now, granted, I know that I'm already talking about statistics and it's only our 2nd class session, guys. Don't freak out on me, okay? We're good? Because I read y'all's discussion board post and a lot of you had concerns about this particular issue. That's okay. Don't worry. But here with statistics, this is a hypothesis that we always make in statistics, and it actually relates to research. Now, our null hypothesis states the following. It states that there is no effect, it states that there is no difference, and it also states that there is no relationship. Okay, so I'll say it again. The null hypothesis predicts no effect, no difference, no relationship. That's what our null hypothesis predicts. No effect, no difference, no relationship. So if you're comparing 2 groups, let's say for instance you're comparing men and women on aggression levels, the null hypothesis always predicts that men and women don't differ. Everyone good? Perfect. The alternative hypothesis, just like the name creatively sounds, what do you guys think the alternative hypothesis predicts? The alternative of the null, exactly right. So if the null predicts that there is not going to be a difference, the alternative predicts that there will be a difference. Oh, am I breaking up? Too much already, or is it better? Okay. Yes, absolutely. So remember, the null hypothesis predicts no effect, no difference, no relationship. The alternative hypothesis is going to predict the difference of that. So in other words, it's going to predict the alternative. It's going to say there is a difference, there is an effect, there is a relationship. Okay? Now, these are statistical in their nature. And what that means is that we assume that these 2 hypotheses, these 2 exist out in the real world. Okay? So this prediction here and this prediction here, this is the real world. Can you all see what I'm writing? Okay, perfect. The wonders of technology, right guys? It's awesome. Okay, so this is the real world. In the real world, there's only two possible results that may exist. Either the groups differ or they don't differ, and that's it. There's no other option. It's like flipping a coin. You flip a coin, it can only land on heads or tails. If it lands on its side, kick the coin away because it's probably possessed and that should never happen, okay? So here you flip a coin, it should land either on heads or on tails, and that's it. There's no other third option for us. Everyone clear? In statistics and in research, we're always looking at the null hypothesis, okay? Specifically in stats. In stats, we always look at the null hypothesis. And the reason we always look at the null hypothesis is because the null hypothesis tells me that the difference between my groups should always be equal to 0. Hence, it's right there. Okay? So in other words, if we have the average for men and we have the average for women on aggression, the null hypothesis always predicts that the average for men and the average for women will be equal to each other. They will never differ. Is everyone clear? Okay. That difference, if these two averages are equal to each other, then the difference between them would be equal to 0. The alternative hypothesis, on the other hand, tells me the following. Men and women, they will not equal. They will never be equal in terms of their scores. So the difference between their scores will not be 0. Is everyone clear? Okay. Now, why then is it telling me that it should not be equal to 0? Because it's giving me the alternative of the null. The null is telling me it should be 0. The alternative then tells me, well, it shouldn't be 0. The problem that we have with the alternative hypothesis is the alternative hypothesis doesn't tell me what that number should be. All that the alternative hypothesis tells me is it's not 0. That's it. I don't know anything more. Over here, I have a known value. That known value is a 0. Does that make sense to everyone? Okay. So what we do in statistics and in research is we always look at the null and the alternative hypothesis. And we look more specifically at the null hypothesis because it gives me a value to work with. The alternative hypothesis is there and it works. It's fine. But to be honest with you, the alternative hypothesis is really it has no other use except for it's just that the groups aren't equal. There is a relationship and there is an effect. That's all it's ever going to say. Questions up to now? Everyone good? Perfect. So one of the things that we can have is that we could potentially have multiple alternative hypotheses. Now, what do we mean by this? What we mean is the following. Let's say, for instance, that again, we were making the comparison of men and women, right? So we're comparing men and women on their regressive behavior. The alternative hypothesis has multiple options that we can pick from. Because remember, the null tells me they shouldn't differ. The alternative tells me they should differ. But it should also tell me who's going to have more aggression and who's going to have less aggression. So for instance, our alternative hypothesis, one of the options could be, oops, sorry about that. There we go. Men will have higher scores than women. Everyone with me so far? That is one possible prediction that we can make. So here we're not saying that they're equal. Here we're saying that they're not equal. Okay? Here we say that they're equal. Here we're saying that they're not equal. Men are going to have higher aggression scores than women. Thus, the difference is not going to be equal to 0. Men are going to be more aggressive than women. The second possible alternative hypothesis that we might have, what do you guys think is going to be? If men are more aggressive, what do you think the second possible hypothesis could be? That women are going to be higher aggression. Now here we don't say that women are going to be less because here that's a given here. Okay, men will be more aggressive, meaning that women will be less. Here our second hypothesis could potentially be women will be more aggressive than men. Now here you're probably asking yourself, well, can we ever have an instance where we have both? And the answer is no, you can't. You can't have an instance where you say, I'm going to flip a coin, it's going to land on heads, and it's also going to land on tails. You can't do that. You can only have one of these options. Is everyone clear? Okay, so here you can only have the option of saying the groups are not going to differ. You can only have the option of saying the groups will differ, and if the groups do differ, who's going to have higher scores and who's going to have lower scores. That's it. Either men are going to have more aggression or women are going to have more aggression. You can't tell me men are going to be more aggressive than women and also women are going to be more aggressive than men. I don't know how that's going to happen. That's impossible for that to happen. Everyone with me so far? Perfect. Now remember, where are we going to get this hypothesis from? We're going to get it from the previous literature, meaning that we are going to do research on men, on women. We're going to look at aggression levels and we're going to try to make decisions about what it is that the literature tells me about what's been previously found. In other words, other researchers have looked at the comparison of men and women on testosterone levels, and they find that testosterone levels in men are greater than in women. And we find that there's a relationship in testosterone to aggression, meaning the more testosterone that you have, potentially the more aggressive you will be. So thus, we draw the bridge and we make this bridge between the two areas, and we say to ourselves, well, if men have more testosterone than women, and more testosterone leads to greater aggression, I'm going to assume here then that men are going to be more aggressive than women in that particular case. Everyone good? Perfect. Questions so far? All right, perfect. Now, one of the things that you guys are going to read in your textbook is that Goodwin talks about the research hypothesis and the alternative hypothesis as being the exact same thing. This is a problem for me because you'll notice here that whenever it is that we talk about the research hypothesis, which is this one right here, which is the one that's based on the literature, that's your research hypothesis, okay? So we have our null hypothesis, we have our alternative hypothesis, and then we have our research hypothesis. The research hypothesis is the one that we are making the prediction about in terms of our experiment, okay, or our research study. In your textbook, Goodwin talks about the relationship between the alternative hypothesis and the research hypothesis. And he mentions on there that they are the same thing. I'm going to tell you that they're not. This is one of the few times that I will ever disagree with what Goodwin says. And the reason I'm going to disagree with what Goodwin says is for the following reason. There may be an instance that we are doing a research project where we predict that there's not going to be a difference between our scores. Everyone with me so far? Okay? So in other words, I'm stuck in the sand. I know that when I press the accelerator, I don't go anywhere. In other words, there's no effect. I already know that this is going to happen. I already look at the previous literature. Why would I ever expect when I press the accelerator, I'm going to have the prediction that something will happen? In other words, the alternative should exist. If I already have the evidence that tells me that nothing should happen. That's the problem that I have here with what Goodwin says. So in other words, there are some instances where we make a prediction where there is no effect. There is no difference between the groups. We're predicting that nothing should happen. But yet, why do I always have to predict that there is going to be a difference, that there is going to be an effect, that there is going to be a relationship? And the reason that many researchers talk about this as them being equal to each other is that this is what makes research interesting for us. No one wants to read research articles where we predict that there should be no difference between the groups. But rather, we want to read research articles where you're using this technique versus this other technique, the groups are going to differ. But the reality is that that's not always going to be the case. Questions up to now? Everyone good? All right, good deal. And remember, guys, I did post these slides up on Blackboard too, so if you guys do need copies of these slides, they are up there for you. All right, so this is now where we want to now begin to implement the idea of a research design. And research designs are very, very important for us for one very specific reason. Research designs are here to help us answer our questions that we may have, okay? Now, a research design, whenever it is that I talk about a research design, what do I mean by that? I mean any tool, any technique, any method of collection of data that we use that's there to help us answer our potential question and test our hypothesis, okay? A research design should never be the purpose of research. So let me give you an example of that. Let's say, for instance, my department buys me this stapler. Can everyone see my stapler? Okay. So here's my stapler. So my department buys me a $5,000 stapler because I need it for a research project. I told my department chair, I called Dr. Healy and I say, hey, Dr. Healy, you know what? I'm doing a really interesting research project. I need this specific stapler. It costs $5,000. And she says, okay, that's fine. We'll give you $5,000. And I buy my stapler and I'm very excited and I use my stapler in my research study. And I answer my research question, I tested my prediction, I published my paper, and now what do? I grab my stapler, I put it in my drawer, and it's going to stay there for quite a while until I come up with another research study that may potentially use this same stapler. Okay? There is no guarantee that I'm ever going to use this stapler again for a research project. There's no guarantee of that, and I don't want a guarantee of that. The reason for that is the following. Once I let this stapler dictate to me what kind of research I need to be doing, I'm never going to be able to create a research question. So in other words, let's say that someone buys you a car because you needed a car, right? I need to go to school, I need a car. So someone buys you a car. And now you're done going to school and the car is parked because you work from home 24/7. You don't need the car to go anywhere. But now the person who bought you the car comes over and goes, hey, how's that car working out for you? Are you using it till its fullest? You're going to say, yeah, of course I am. I use it all the time. And immediately what you're going to do is you're going to get in the car and you're going to go and do random stuff that don't really require a car. I use my car all the time. I go and check my mailbox that's right outside my door in my car. I get in, I pull out to the end of the driveway, and I go and check my mailbox, even though it's 5 feet away from the door, but I still use the car. Really good use of my car. So my point is the following. You now start using this technique, this design, for anything that comes up, even though it's not appropriate to use it. Everyone with me? This becomes a really big problem for us. And we end up getting caught in this vortex of, I can't come up with a research idea because I'm so driven by using the stapler, by using this design. If you guys notice up there, do you guys see that on the top of my desk or on top of my shelf? Okay. Yeah, those boxes up there. Yeah, so there's a brain. You guys see the brain, and don't ignore the coffee machine. But yes, behind that, there are some boxes. Those boxes have little reaction time boxes. I used to use these back in my research studies many, many years ago. And when I was doing my doctorate, I asked my department for them. And they bought me 4 of them. Each one cost $500. So they gave me about $2,000 to buy these boxes. And I used the boxes, great, and I put them back in their boxes. So I put the box back in the box. And I put them up there. And I finished my doctorate many years ago. And I recently put them up there. I had them in another box. I had them in 3 boxes, apparently. But I just had them stored. And my department chair many years ago came and asked me, oh, what are you doing with those reaction time boxes? And I freaked out. And I freaked out because she was questioning me in terms of what I was doing with those reaction time boxes. They gave me all this money, and I used them one time. And I got really worried. So what did I do? I dusted them off and I said, no, they're right there. I have them planned to being used for another research project. I hooked them up and I sat in front of the computer thinking about what I was going to do for my next research study. And about a good solid 6 months passed and I still hadn't come up with a research idea. And why? I was so driven by that technique that it wouldn't let me generate the question. But rather, what do we know? We know that research designs are there to help us answer the research question. That's why we design the research question first, and then we come up with the techniques. That's why then we end up buying the stapler, not having the stapler first, and then wanting to come up with the research question. This is why that's a very bad idea. Questions so far? Perfect. So again, we always want to identify the research question first because the research question is going to then help me identify whatever type of research design is going to be the most appropriate for me to test my hypotheses that are used to create my research question. So in other words, I've come up with my research question, now I can come up with the research design. So let's say, for instance, I want to look at the differences between men and women in a 24-hour period on their regression levels. Okay, that's our research question. the differences between men and women on aggression within a 24-hour period. How do you guys think we should collect data? What do you guys think we should use? Okay, potentially a survey, right? So we can give out we can give out men and women a survey in terms of their aggression, and we can ask them, right, in the last 24 hours, how aggressive you've been. Exactly correct. What other options are there? Sure, maybe we follow them around in a creepy fashion for 24 hours. Who knows, right? So here, what's that? That's right, exactly correct. You got plenty of time. That's a part of the design. I need time to be able to collect my data. So what do? I walk around and I follow these people around for 24 hours and I see how aggressive they are within those 24 hours. And I mark them on a piece of paper. Now you are able to come up with research designs. But if I give you a reaction time box, just like I have up there, and I put it in front of your face and I go, use it. Use it till its fullest advantage. You're going to look at me and be like, I don't know what to do with this. Even though you may know how to use it, you're still going to tell me, I don't know how to use this. Because you don't have anything in mind that you want to even test at the get-go. Okay? Now that I have my research question, it's a lot easier for me to come up with a research design that I can collect data with because I already know what direction I'm going in. Questions so far? Perfect. Is this stuff making sense to everyone? Perfect. Good. That's what I like to hear. All right. So what's the moral of the story here? The moral of the story is never pick a design, never pick a paradigm, never pick a technique prior to identifying the research question that you want to answer. This is why so many people stress out whenever they're coming up with a thesis idea or they're coming up with a dissertation idea. And the problem is they're already thinking about how they want to collect data, but they don't even know what they want to collect data on. They've been trained for months, years even, on how to do observational data, on how to do survey development, how to do this type of therapy. And now they're caught in that storm. And because they're caught in that storm, it hinders them to be able to come up with a novel research idea that they can use. But rather, research designs, the paradigms, all the techniques that you're ever going to talk about in any class, think of them as tools. They're there. They're there in your garage, in your cabinet, waiting to get used. Not that you need to use them every single time you're going to go and screw in a nail into the wall. You don't have to use a hammer because that's not the appropriate technique. You technically could use it, but it's not going to be very effective. But rather, you have all those tools at your disposition so that way they can potentially help you answer those questions when those questions come up. So here, we should always select the most appropriate design whenever it's feasible. Now, going back to the nail and the hammer scenario here that I was talking about. So here, let's say, for instance, you don't have a screwdriver or a drill to be able to screw in this screw into the wall, but you have a hammer. You know what? It's not going to do the best job out there, but you can use it. I mean, it's all right. I mean, you'll get half of the job done or most of the job done, but it's not the best solution. But rather, what should we do? Hey, I have enough money to go buy a drill. I need a drill for this particular project. Let me go and buy the drill. Hence, I need a stapler for this project. I could get one of those little dollar staplers. That would be the exact same thing, I guess. It would be somewhat effective, but it's really not what I need. I need the wow factor from this swing line one, right? Because this is my stapler and I need this particular type of stapler. And it costs a little bit more, but I got the resources. What am I going to do? I'm going to use it. Now here, for instance, since I can't see you guys, who said that they had enough time to walk around behind people and collect data? Hi, Ashley. Hi, I can't see you, but you guys can see me. So, Ashley, in your particular case, let's say, for instance, that you said, you know what, I don't work, I don't go to school anymore, all I'm working on is on my thesis. I need to collect data. I mean, I could follow these people around for 24 hours. I mean, that would be the best strategy. I mean, I don't want them to know that I'm collecting data, so I can hide behind a door, behind bushes, and I can, monitor them how much they actually are aggressive within that 24-hour period. But you know what? I don't know. I've been really wanting to catch up on the Kardashians, so instead, what am I going to do? I'll just give them a survey. It'll be fine. It'll be the exact same thing. Is it the exact same thing? Definitely not. There's pros and cons to each design, isn't there? Absolutely. So here, what should she do? She says, hey, you know what? Gathering data through observations is going to be the most effective tool, the most effective technique. It's going to give me the best valid results that I could possibly get. But just because I'm lazy, I'm not going to do it. So I'll just do this other lazy fashion. Well, no, that's where we're going to end up having problems. So here, what should we do? We should be able to go out and do that data collection because we have time. We have the resources. That's what we're driven to do as researchers. Does everyone understand me? Perfect. Now, what happens in the case where you don't have the time? So let's say, for instance, Ashley doesn't have the time, but one of her other friends does have the time. Hey, you know what? I don't have time to go out and collect all this data, but you're not doing anything. Will you help me out and gather my data for me? Please, I'll pay you $50 an hour. That's incredible, right? I would do it too. I would quit my job. But here, it's a great opportunity. You're going to collect data. You're going to really help out the cause. So here now, she still implements the exact same technique, even though she doesn't have time, but she's able to use those resources up that she has in terms of paying that person to go and collect data. Any questions so far? Perfect. Now, she doesn't have time. No one else around her has time. What is she left with? I can only do survey data collection at this point. I'm limited by my logistics. Perfect. At this point, do what it is that you can. Or the stapler costs $5,000. My department's never going to give me $5,000. They've told me I can go to the dollar store. I'm buying the dollar store stapler. That's what's about to happen. Questions, concerns? Perfect. So ultimately, whenever it is that we're going to select a type of design, so here a question then becomes, so is it that you're only driven by resources? Are you only driven by time? And the answer is no. But rather, I'm also driven by theory. I'm driven by what the literature tells me is the best technique. So if we already know that there's a technique out there that's been discarded, it's not useful anymore, it's outdated, it's rudimentary, hey, you know what? Don't use that technique anymore. Use a newer technique, even though it might be a little bit more expensive, even though it might take you a little bit more time to do the data collection, even though it may take you a year or two to be able to defend your dissertation. But you know what? At least I'm gathering the best data that I possibly can. Or a friend of mine has that resource. A friend of mine has an fMRI machine, and I really need one. Well, ask your friend if they're able to help you out. And to be honest, that's one of the ways that we do a lot of our research, that we end up having collaborators on our research projects because they have other types of resources that we don't have. They may have more time. They may have a special population that they have easy access to. They may have money. They may have that specific technique or that paradigm that allows for data collection that we don't. So thus, we reach out to them and, hey, I need a collaborator on my project. I'll let you be second author on the project for just letting me use your equipment. And we say, all right, now you got yourself a deal. Questions up to now? Everyone good? Awesome. All right. We'll take a break in about 9 more minutes. Give me a chance to go through a couple more slides here and we'll take a little bit of a break. All right. So when we think about designing or designing a study for hypothesis testing. So in other words, I have my hypothesis. So receiving a grade of an A on an essay test is going to improve self-esteem on the Heatherton and Povey subscale from pre-test to post-test. If we already know what my hypothesis is, I now need to design my data collection process. I need to design my study so that way I can be able to gather my data. So when we think about designing our research studies for testing our hypothesis, because that's what we do in research, we're hypothesis driven, we're testing hypothesis continuously. We are now going to look at different components associated with research designs. And there's actually 5 different components that we're going to look at, okay? And we're going to go through all 5 of them today. Number 1 is what we call the nature of the data measurement. So in other words, what kind of data are you wanting to collect? Or do you want to collect qualitative versus quantitative? What kind of data do you need for your specific hypothesis testing? Number 2, the nature of the study setting. Where do you want the study to take place? Do you want it to take place in the lab under very controlled situations? Or do you want it to be out there in the real world where there's a lot of error variance that we talked about on Tuesday? A lot of other factors that might contribute to your effect. Number 3, the nature of the variables and their control. So in other words, are we doing experimental types of research or are we only doing correlational types of research? And that has pros and cons to doing each. Number 4, the nature of participation. Do you want the same participants over a given period of time? Or do you only want different groups of individuals at one time frame so that way you're done quick and easy? There's always, again, pros and cons. And last, the nature of the study's purpose. So what's the point of you actually having done this research study? Is it just for us to gain more knowledge about the topic? Or do you want to implement it out into some real world situation so that way we can be able to use it out in the real world for a real world problem in that particular case? All right, so let's get into talking first about the nature of the data measurement. So like I mentioned, whenever it is that we're wanting to collect data from participants, data can be collected in 2 different forms. The first way we can collect data is through what we call qualitative data collection or qualitative designs. Whenever it is that we do qualitative data, which probably many of you are very familiar with, we collect data in narrative forms. Has anyone ever used qualitative data collection? Anyone? No? Yeah, a couple of you? Sorry, remember I can't see you guys. So a couple of you have used qualitative data. With qualitative data, pros and cons. Who said yes? No? Oh, okay, sorry. Oh, sorry. Okay, so in terms of qualitative data, okay, so let's say, for instance, you're doing an assessment with the participant, right, with the patient in your particular case, and let's say, for instance, you ask them, "How's your day going?" And you want to get a feel for if they're suffering from depression or not. Now, easily here, we could give them a survey and we could collect data through numerical formats, what we're going to call quantitative data, and we're going to look at your score on a survey or on an assessment, and we're going to say, yep, you have depression or not. That could be one way, but maybe we want to tackle a specific depressive issue, right? So let's say, for instance, the depressive issue is your mother, okay? Not that my mother is a sensitive topic, but to still bring up my mom, guys, okay? Everyone good? Yes, okay. No. Just joking, guys. I love my mother very much. Okay, so let's say, for instance, about your mother, right? So what we do is we say, how's it going? How's your day starting? And what we do is we start transcribing what they're saying. We let the participant or the patient speak freely, and we hope that through free association, they'll sooner or later get to the point where they're going to talk about their mother and they're going to reveal to us the underlying psychological issues that may be leading to them suffering from depression now. Okay? So here, one of the things that we're going to do is we're going to collect data in this narrative form. Generally, what we're going to do is we're not going to sit there and we're going to sit there with a pencil and paper and be like, okay, let me write down everything that you just said to me. No, that's going to be impossible for us to do. On average, humans can produce somewhere between 400 to 500 words a minute. If you're interviewing someone for 45 minutes in a therapy session, that's a lot of words, isn't it? So rather, what do? You let them talk, you record it, and then later you go back and you transcribe everything that you just recorded. So you listen, you transcribe, and then after you transcribe, you go through and you try to identify a pattern in terms of what it is that they've given to you in terms of speech. And here, that's a very good method of data collection. Now, as you can imagine, when we have one participant, okay, when we have participants equal to 1, not a problem. You got one person that you're doing this with, not a problem. If you have more than one participant, this becomes problematic. So let's say, for instance, you want to collect data on 500 individuals. In a qualitative design, you're going to record them for 45 minutes. Then you're going to go back, you're going to listen to the audio, you're going to transcribe everything. Generally, they say that for every 30 minutes, it takes an hour to transcribe, just so that way you can get everything correct. So for 45 minutes, you're talking about an hour and a half to 2 hours times 500 participants. That's a lot of hours that you're going to put in to just data collection and transcribing. Plus now analyzing all that data and trying to answer your hypothesis. So here we see that there's that limitation associated with the qualitative design. It gets to be too cumbersome for us. It gets to be just too much information. Now, one of the advantages, as you guys can assume, I get lots of data. So if I let you talk for 45 minutes, as I've been doing, it's going to let you gather a lot of information. A lot of it may not be useful. Don't worry, a lot of the things I say, like my mother, don't really mean anything. But a lot of the stuff that's there might be meaningful. So what do I have to do? I have to sift through everything so that way I can try to find the really important stuff. So I talk for 45 minutes, but only 2 minutes are even important content. Well, I had to sit there for 45 minutes, transcribe, and analyze to get to those 2 very important pieces. So again, qualitative data, the disadvantage, it becomes too much information whenever it is that we have more than one participant. The advantage of using qualitative data is that we have a lot of information that we've collected. Hopefully it'll all be really important, but that's not always the case. Questions? Perfect. Now our second technique that we can use, or the second type of design that we can implement, is what we call a quantitative design. With quantitative design, this is where we're going to gather a lot of information in numerical form. So in other words, you're going to be using surveys, you're going to be using observational data and marking how many times they actually had aggressive acts towards another person. You may give them an assessment. You may ask them to memorize a list of words. They tell you how many words they remember. That's the number of words or the proportion that they recalled, etc., etc., etc. We have number format. Now, number format is very, very good for us. The benefit of having that number, it's quick. It's easy for me to gather that data. It's also very useful because I can apply statistical analyses to it. Okay? I can actually apply descriptive and inferential statistics. I can calculate an average. I can calculate a range. I can calculate a standard deviation or a t-test or an f-test, whatever the case may be. I can calculate all those stats if I have numbers. I can't do that with words. Now, one of the disadvantages that I have with quantitative data is that with quantitative data, I now lack detail. So the benefit of qualitative designs were that I have the vast amount of detail. I have all this information. They express a lot of information and explain a lot of things. That's good. The problem now that I have with quantitative data is I got a number that tells me how you feel. Now, many years ago, this actually happened to a friend of mine when I was in graduate school. She designed an emotion survey, and she gave it to a participant. We were pilot testing it, and we had the scale go from 1 to 9. And it said, on a scale from 1 to 9, how do you feel today? 1 being, I feel very sad and very depressed, and 9 being, I'm very happy, very joyful, and very excited in my day. And the participant answered a 5, right smack in the middle. And we all looked at that, and we thought about it, and we were like, oh, what does that even mean, right? So she turned it in, we had to fill out some other assessments, and we're all looking at this, going like, what does a 5 even mean on this question? How do you feel today? She answered a 5. So after the session was done, we asked the participant, hey, can you come here? We have a question. Good thing is that we're pilot testing this. And we asked her, what did you mean by a 5 on that question? And the participant looked at us dead in the eyes and said, well, like I don't feel, and I don't feel like, like, and we all just stared at her and we're like, what? And she realized that we were still really confused. And she said, well, I have middle feelings. Middle feelings. I had never in my life heard that. And I thought, what is middle feelings? And we all just said that. And the participant was like, anything else? And we were like, no, you can go. Left the room. And we all sat there going, like, what does this even mean? How can we even understand this person's emotion behind this one single number of a 5? And the response is like, I don't feel like and I don't feel like and I have middle feelings. It was pointless for us to gather that kind of data. So what did we realize? We realized that we had to interview participants to really gather their emotional states at that point. Questions, concerns up to this point? I got very excited and my earbud got out. Sorry. Questions up to now? Everyone good? Perfect. All right. Okay, so let's take a little bit of a break. I have on my watch 5:02. Let's take a 10-minute break. We'll come back at 5:10 and we'll pick class back up. All right? So take a little bit of a break, go to the restroom, take a breather, and we'll be back in just a couple of minutes. All right. Qualitative versus quantitative design. So let's go ahead and now move into our second point of discussion here, which is the nature of the study setting. So where is it that your study is going to be taking place? Now, here, whenever it is that we talk about the nature of the study setting, realize that there are different settings where your study could be. It's just the way that we classify these different settings as X or as Y. Now, the two types of study settings that we have are either that you do your research study in the laboratory setting or a laboratory design. And here, whenever it is that you think of a laboratory design, think of it as even being something like, I'm doing it in the classroom, I'm doing it in my clinic, I'm doing it in my office where I counsel people. Any situation that you can think of that is not classified as the real world, that's out there in the real world, we're ultimately going to classify it as being a laboratory design. So here we have an obvious research setting where we have a very well controlled situation by the researcher. Now, this is going to be very, very important for us that we have this very well defined and very well controlled setting. And the reason we want such a well controlled setting is because, again, I want to try to reduce error variance. So remember, we talked about this on Tuesday of last week. What is error variance? Can you guys tell me what that is? Don't you hate it that I make you go back to your notes? Say that one more time. Yes, but why is it a mistake, or why is it error? What makes it an error? Perfect, exactly correct. So in other words, error variance is differences in our scores that are not due to the researcher's manipulation or control. So I'll say that one more time. Error variance is differences in our scores that are not due to the researcher's manipulation or control. So in other words, we are collecting data, but some of that data comes in dirty. Okay, and it comes in dirty because we assume that it's clean, but we realize that there are nitty-gritty aspects associated with your data that aren't necessarily accurate. Okay, so what do we have to do? Generally, we have to make sure that before the study ever starts, we try to clean out any potential error variance that may contribute to the differences in our scores prior to the start of the study. So in other words, I have to make sure that I've designed a really good study before the start so that way I make sure that the data that I am gathering is valid, it's reliable, and that I'm going to be able to publish something that's good quality work that's going to be impactful to our field. And not something that people are going to look at and be like, what? This is junk. This is completely riddled with mistakes and riddled with flaws in their research design. But rather, we have a very well-controlled situation. And laboratory designs allow us to be able to do that. Now, laboratory designs are going to be very, very important for us whenever we're trying to establish definitive causality. In other words, when I'm trying to definitively state that A causes B, in other words, my independent variable is the causal mechanism for my dependent variable, whenever I'm trying to make that relationship, and for me to have a laboratory design where I've controlled all other possible factors that might contribute to my effect. So that way I'm only left with saying that A caused B. In other words, laboratory designs need to have a high degree of what we call internal validity. So I'll say that again. Our laboratory designs are going to have a high degree of internal validity. What is internal validity? A high degree of control in our research situation. So a high degree of control in our research situation for internal validity. By having that high degree of internal validity, I should be able to reduce error variance. Questions so far? Everyone good? Now, the opposite of doing a laboratory design is going to be doing the study out in the field. Now, as you can imagine, when you're out in the real world collecting data where you have a less obvious research setting and that you as the researcher don't have a very well-controlled situation, it's going to be very, very hard for me to be able to establish definitive causality. And the reason for that is because out in the field, out in the real world, there's going to be a higher degree of error variance. So in other words, there's going to be more factors that are going to influence my results other than the things that I'm manipulating and I'm controlling, but rather there's going to be other factors, the noise in the atmosphere, the smells outside, the temperature, X, Y, Z, all of these different things may potentially hinder my ability to collect the data in an accurate fashion. So here it's going to be very, very difficult for me to be able to have a reliable assessment tool and also a valid tool later on. Okay, so with field designs, we are going to have lower internal validity, but generally what we end up having with field designs is we have greater external validity. So I'll say it again. With field designs, we have lower internal validity, but we have higher external validity. And external validity means how well my results can apply to the real world setting. So how well can your results apply to the real world setting? That's the issue associated with external validity. In the field, we have a high degree of external validity because we're doing our research study out in the field. We're doing it out in the real world. So how are your results going to generalize to the real world? Well, it works really well when you're doing it out in the real world. Versus in the laboratory setting, which is not anything like the real world, it's a very well-controlled research situation, you generally have less external validity in the lab. So in the lab, less external, high internal. In the field, you have high external, low internal. Questions up to now? Everyone good? So here you'll notice that I've already gone through two very crucial points associated with how to pick a research design. Either you collect data through qualitative fashion or through quantitative fashion. You either collect data in the lab or you collect data in the field. And none of these designs have told you this one doesn't have any disadvantages. They all have disadvantages. They all have limitations. They all have flaws. And that's one of the problems that we have with doing research, is that there is no one flawless type of design that will always give us 100% accuracy. But rather, what do we have? We have research designs that are the best ways for us to answer the research questions and test the hypotheses at this time. And they come with limitations. And we all have to bite the bullet and say, all right, well, there's limitations that come with it. And that's that. Questions up to now? Perfect. Let's move on to point number 3, the nature of the variables in their control. Now, whenever it is that we're talking about the nature of the variables in their control, we're talking about using two different types of research designs. Either a true experimental research design or what we call a correlational research design. A true experimental design or a correlational design. And I'm going to talk about what both of them mean. So let's first look at experimental designs. The purpose of a true experimental research design is going to allow us to draw conclusions that one variable caused another variable. So in other words, my independent variable caused my dependent variable. So A causes B. I study for 4 hours, that causes me to have a 95 on my test. That's what a true experimental design would allow you to conclude. It's all about the conclusion that I'm drawing. That's what it's all about. The type of conclusion that I'm drawing with point number 3. So with true experimental research designs, they allow you to draw causal conclusions. So again, I study for 4 hours, I get a 95. I study for 8 hours, I get 100. So here I know the causal mechanism for me doing better. Okay? Now here with true experimental research designs, I need to be able to establish 4 specific criteria. And the 4 criteria are what we call random sampling, random assignment, have an independent variable that's manipulated in its nature, and have a high degree of internal validity, or this idea of control. Those are my 4 criteria for a true experimental research design. Having true random sampling, having true random assignment, a manipulated independent variable, and have internal validity. Those are my 4 criteria. Now, what do each mean? With random sampling, this is what we mean by random sampling. Everyone in the population of interest has an equal probability of being selected for your study. That's what random sampling refers to. Everyone in the population of interest has an equal opportunity of being selected for your participation. That's true random sampling. Now you'll notice I mention every person, every individual who fits that criteria for your population. So in other words, if you're wanting to look at the differences between, I don't know, we'll say introverts versus extroverts, let's just say. So I want to know the difference between introverts and extroverts on motivation. And you don't specify who your populations of interest are, except that they have to be introverted and extroverted. That means if you want to do true random sampling, you give everyone from the population, everyone, an equal opportunity to participate. That doesn't mean you give students from Our Lady of the Lake an equal opportunity to participate. It doesn't mean that you give people from the city of San Antonio an equal opportunity to participate, or Texas or the US, but it means globally you should give everyone an equal opportunity to participate, because that's what you've said you were going to do. You're wanting to look at the differences between introverts and extroverts. Everyone with me so far? Now, how likely is it that we're going to do that? It's not likely at all, and we don't even do it, to be honest with you. So rather, if we don't do true random sampling, what are we left with? We're left with something that we call convenience sampling. Convenience sampling. That's what we're left with, convenience sampling. And just like the name sounds, it's sampling that is, what do you guys assume? It's convenient to me, exactly correct. So here, what do? I'm a psychology professor at Our Lady of the Lake University, and I have a bunch of students who are taking a psychology class. I'm about to offer some extra credit for participation. That's what's going to happen. That's my convenient sample. They are people that I have easy access to. That's what convenient sampling is all about. We have people that we have easy access to. That's who we use, and we use their results to generalize to the larger population. So again, very rarely, if ever, do we do true random sampling. Rather, we do convenient sampling. People who are easily accessible to us, we use them. We use them to make inferences about the larger population. This is why when you read literature that comes from psychology, about 95 to 96% of research studies use... Oh, sorry about that. Is that better? Okay, so when you guys are reading psychology literature, one of the things that you'll find is about 95% of participants that they use in their research study are college students. They're generally general psychology college students. And the reason that we do that is because we have easy access to them. They're right there. They're freshmen. They come in. We put it in as part of the course that they have to participate in research. We make them go into laboratories, give us their data, and we give them course credit for doing that. So here, they're easily accessible to us. Granted, that's not exactly the best strategy for us to make inferences about the population, but you know what? At least that's what we got. And we do so unforgivingly, to be honest with you. Questions up to this point? Perfect. Okay, second criteria, random assignment. Random assignment means that the people that you randomly sampled, they are given an equal opportunity to be in any one of your groups for your study. I'll say it again. With random assignment, the people that you randomly sampled, they should be given an opportunity to be able to be in any of your groups of your research study. Now, that's not always possible. It's not always possible because there are things that we research that don't allow for us to do random assignment. So remember, with random assignment, everyone has to have an equal opportunity of being in any one of my groups. So let's say I have two groups. I have male and female. Do people have an option of where they're going to go? No, they don't. They go to the group that they identify with. So they come in and they say, I am male. And I go, oh, I'm really sorry. We're implementing random assignment today. Let me roll the dice and see what group you get assigned to today. Definitely not. But rather, the participant comes in and says, I'm male. You automatically go into the male group. So I fail to have true random assignment at that point. But there are some factors that I can have true random assignment. So let's say, for instance, I have a high anxiety group and a low anxiety group. I can create anxiety. I can give people a high anxiety situation to put them in high anxiety groups, and I have individuals that I can put in a low anxiety group and I can force them into that group, and I can randomly assign them to the groups and then be able to implement that manipulation. Does everyone understand that? Questions up to now? Perfect. Okay, factor number 3, a manipulated independent variable. Now, when we talk about the independent variable, this goes back to the issues related to 5th grade and 6th grade science. In 5th grade and 6th grade science, one of the first things that you all learned, aside from a hypothesis, was the aspect of an independent variable. That was the very first thing. And they always talk about what the independent variable is. And that's always the factor that you manipulate in your research study. In true experimental research designs, that is true. That is the factor that we manipulate, okay? In other words, that's the factor that has to be under my direct control. So in other words, the high anxiety situation or the low anxiety situation. I can produce high anxiety or low anxiety. It's manipulated. I control that. Everyone with me? Perfect. Now, this doesn't always happen that I have an independent variable that's manipulated. Let's go back to our example of male and female. Let's say I want to look at the differences between males and females on aggression. Again, I'm not controlling males and females. I can't control their genders. I can't randomly assign them to the male or female group. But rather, what can I do? I can observe that factor. So participant A comes in and they tell me they're male. They automatically go to the male group. Participant B comes in. They tell me they're female. They automatically go to the female group. I still have an independent variable. It's just not manipulated. It's what we call an observed independent variable. So I'll say it again, an observed independent variable. That's an independent variable that we just observe that the participants come in with. That's it. It's not under my control. For a true experimental design, it has to be under my control. If I have something like gender, if I have something like personality, if I have something like socioeconomic status, those are things that the individual comes into the research situation with and I cannot control. So thus, those are observed. Questions up to now? Perfect. Point number 3, internal validity. We just talked about internal validity in our previous slide with laboratory designs and field studies. And remember, with internal validity, what I want to do is I want to have a high degree of control in my research situation. So what do I want to do? I want to be able to say that factor A does truly cause factor B and that all other possible mechanisms have been ruled out. So in other words, it couldn't have been their socioeconomic status. It couldn't have been their gender. It couldn't have been their political affiliation or this or that. But rather, it's just that one single factor that's the causal mechanism. Questions up to now? Perfect. So here, if we're able to establish these 4 criteria, we should be able then to establish definitive causality. In other words, I should be able to say definitively that A causes B. that my independent variable caused my dependent variable. So here again, highlighting the issue associated with cause. Okay? Now, there are disadvantages that come with using a true experimental research design. And some of the problems that we have with a true experimental research design are that, well, number one, it's really hard for me to meet these 4 criteria. It's really hard for me to be able to meet true random sampling. It's really hard for me to meet true random assignment if I don't have a manipulated independent variable. It's really hard for me to also control all other possible factors in a research situation. So rather, what am I left with? I'm generally left with the option of not doing a true experimental research design because very rarely, if ever, do I do them. Rather, I'm left with what we call a correlational research design. Now, the second issue that we encounter with doing true experimental research designs is that we have a lot of difficulty fulfilling what we call the conditions of causality. Now, what are the conditions of causality? The philosopher David Hume, actually back a long time ago, gave us 3 very, very important conditions that needed to be met aside from these 4 criteria. So aside from these 4 criteria that we've just established, true random sampling, random assignment, manipulated IV, and have a high degree of internal validity, David Hume also proposed for us that we had to meet 3 very important conditions of causality, and we're going to go through those right now. Now, before I begin, any questions, any concerns at this point? Everyone good? Perfect. All right. So with our conditions of causality, what are we referring here? Well, remember that David Hume proposed for us that what we needed to do in order for us to be able to establish that A causes B, we needed to be able to establish in all possible realms that only A really does cause B. And according to David Hume, I needed to establish 3 very, very important conditions. Now, what are those conditions? Condition 1, a change in A is accompanied by a change in B. Now, what is A? A is my independent variable, B is my dependent variable. So again, A is my independent variable, B is my dependent variable. So here, David Hume said the following. Look, aside from random sampling, random assignment, aside from manipulated IV and internal validity, you need to be able to establish the following 3 criteria, the 3 conditions. When you change A, B has to change. So in other words, when I go from high anxiety to low anxiety, I expect the scores to change. If the scores don't change, what does that mean about my independent variable if my scores don't change? Say that one more time. Exactly right. So in other words, it's not a true representation that that independent variable has an effect on the dependent variable. So let's say, for instance, you want to try out 2 different types of depression techniques. So what you want to do is you want to implement therapy technique A and then therapy technique B. So here, you're manipulating the technique in this particular case, and you're measuring people's depression. So you have group 1, they receive technique A. Here, people in Technique A, they score a 90 on the assessment, whatever that assessment may be. People in the second group, in the second technique, now receive this different technique and we assess their scores. Their scores are also a 90. Both scores are exactly the same using the 2 different techniques. What does that mean about your techniques? Do they change depression or not? Oh, sorry. Where did I stop? Let me ask it one more time. Technology. Sorry, guys. I apologize. Okay. So one more time. So we have technique 1 and technique 2. Okay. So we implement technique 1. People get a 90 on their assessment for depression. We give them technique 2. Now these people also get a 90 on their assessment for depression. What does that mean about your techniques? Do they work or do they not work? Okay, so you may be measuring the same thing, but you have two different techniques and you wanted to know which technique is better. Did you find that out? No, you didn't, right? So here, for whatever the case may be, man, maybe none of the techniques even work at this point. To be honest, they both give you the exact same score. You don't even know what's happening at this point. So here, you changed A, technique 1 to technique 2, but B never changed. How can you ever establish that A causes B? So the technique causes you to have lower depression when the score doesn't change. Okay? We call this rule covariation. This is our covariation rule. So a change in A has to be accompanied by a change in B. So I implement technique 1, people get a 90. I implement technique 2, people get 150. Here, now we know which technique is more effective. Technique 1 is because their scores were lower. Questions up to now? Perfect. Number 2, A must precede B. So A has to come before B. So in other words, my independent variable has to come before my dependent variable. So my independent variable has to come before my dependent variable. We call this the temporal precedence rule. The temporal precedence rule. And essentially what this rule means is the following. If you want to establish that your manipulation has an effect on your dependent variable, so in other words, your IV affects your DV, you need to make sure your IV comes before your DV. Now here you're probably thinking to yourself, well, of course you're always going to implement the technique prior to the assessment, but we just wanted to clarify that according to David Hume. So if you want to make sure that the technique that to lower depression does actually work, implement the technique prior to measuring the individual's depression. Or measure their depression, provide the technique, and then measure the depression a second time with the post-test, and you'll be fine at that point. Questions up to now? Perfect. Number 3, some mechanism can be posited to explain the causal effect of A on B, and alternative explanations are ruled out. In other words, what David Hume was saying was, make sure that the only thing affecting B is A, and no other possible factors might contribute to the effect on B except for A. What did he call this? He called this the internal validity rule. In other words, have a high degree of control in your research situation so that way you can rule out all other possible alternative explanations and only leave A as the possible causal mechanism. That's the most important thing according to David Hume. Questions so far? So according to David Hume, we need to establish, again, random sampling, random assignment. We also need to establish manipulated IV and also have internal validity. And here now he's also saying, and by the way, make sure that when you change A, so you go from technique 1 to technique 2, your scores change. If you also want to establish that A does cause B, make sure that A comes before B. And last, make sure that you eliminate all of the possible alternative explanations and only leave A as the possible causal mechanism as the effect on B in this particular case. Everyone good? Perfect. Now, as you can imagine, this is hard to do. If it was hard to do with our 4 previous criteria, and now we have to establish these 3 conditions as well, that makes it very, very difficult for us as researchers to be able to establish definitive causality. So the reality of the situation is most of us are not going to do true experimental research designs. So I always think of it like this. When I was in 5th grade, I was in 5th grade. Do you guys remember by any chance your first science fair projects? Yes, what was it? If you want to share that. Oh, okay. Anyone else want to share theirs? Some of us are probably embarrassed about our research projects, aren't we? I'm not. I will tell you what mine was. Which paper towel was the most absorbent? It's Bounty, if you're ever wondering. It really is. Still to this day, we only buy Bounty in my home because I'm obsessed that my results are valid. looking back on my work, I can tell you I probably had a little bit of error variance. I'm not going to lie to you. It probably didn't help that the night before I was working on the science fair project, really in a rush to pick up a bunch of water with a paper towel, that I really wasn't even sure if I measured the same amount of water in each time that I was picking it up. I don't even remember if I used only one single paper towel for each one of the picking up of the of those wet puddles that we had made. Maybe in Bounty, I used 5 sheets and I put it on there and it absorbed it really quick. And for the other brand, the HEB brand, poor HEB, right? But the HEB brand, maybe I only used one little towel and it wasn't enough. So here, I still base my results off of that one experience, but well full knowing that I probably had a lot of error variance. So here, is it really that when you use Bounty, that will cause you to pick up a spill faster than any other brand of paper towel? And the answer is probably no, to be honest with you. But you know what? I still take the work that I did and I still use it. And the reason is the following. Maybe it wasn't a true experimental research design. Maybe I didn't have true random sampling or true random assignment or a real manipulated independent variable or a high degree of internal validity. But rather, even though I didn't satisfy all those criteria, I can still use what's called a correlational research design. Now, correlational research designs, the term correlational sounds a lot like another term you guys have probably heard in other classes. What's the term it sounds like? Like a correlation. Exactly correct. It sounds a lot like the term correlation, like the statistic. But what I'm going to tell you here is the following. These are not the same thing. A correlational design and a correlation are not the same thing. A correlation is a statistic. A correlational design is how we collect data. Is everyone good? Perfect. So here, with correlational research designs, the conclusion that we can draw out of our work is not causal in its nature, because you'll notice here that nowhere within there it says anything about cause, but rather it allows me to conclude that there is a relationship between one variable and another. So here, for instance, let's look back at the issue related to both men and women on aggression. If we find that men are more aggressive than women, does that mean that being male causes you to be more aggressive than when you're female? No, definitely not, right? But rather, what can we conclude about that relationship? Exactly right. So on average, men are more aggressive. In other words, you're saying, hey, it looks like if when you're a guy, you tend to be more aggressive than when you're a female. There seems to be a relationship. Not saying that every male is going to be more aggressive than every female, because that's what cause would imply. Because if you're male, that causes you to be more aggressive than females. We're saying that in every instance that's going to happen. But rather, we're saying, well, it seems like if you're male, you're probably going to be a little bit more aggressive than when you're female. That's the conclusion that we draw. So here, is Bounty really the causal mechanism of absorbing the best spills out there? And the answer is probably no. But it seems to be related. So at least I can draw that relationship and I can say, hey, when you use Bounty, it seems that it picks up spills a little bit more effectively than when you use other non-Bounty paper towels. Everyone with me so far? Questions up to this point? Perfect. So here, when is it that we want to use a correlational design? Correlational designs are used whenever it is that we want to attempt to observe if a relationship exists or not. So in other words, do we even see that differences exist between men and women on aggression levels? If we do find that aggression differences exist between males and females, we may now want to go in and explore why, the causal mechanism. But here, we're just trying to observe if that relationship even exists at this potential point. Now, these types of designs are very valuable. And to be honest, 99.9% of us fall into the realm of a correlational research design. If anyone ever tells you, I have a true experimental research design, that essentially means that they're doing flawless research with true random sampling, true random assignment, and a manipulated IV and a high degree of internal validity. And that's not really likely, to be honest with you. But rather, what can we do? We can do correlational research. And by doing correlational research, we're able to establish and examine relationships that are not examinable through experimentation. So in other words, through a true experimental research design, I would never be able to look at the difference between males and females on aggression levels through a true experiment. Why? Because I have to have a manipulated IV where I have true random sampling and I have true random assignment. It's never going to happen. Never, never, never will I be able to do that true experimental research design at this point. Maybe in the future we'd be able to do that, but at this point I can't. So rather, what can I do? I do a correlational design where I draw a relationship conclusion, and at least it sets up the stage for somebody else doing that experimental design in the future. Maybe not right now, but maybe in the future based off of my work. So the La Garza did some work, and they found that men are more aggressive than women. There seems to be that relationship that when you're male, you tend to be more aggressive than when you're female. Perfect. Now in the future, somebody says, hey, now we can manipulate gender and we can switch people's genders back and forth all that we want, and there's not a problem. Perfect. Let's do true random sampling. Let's do true random assignment. I have my manipulated IV, and now I do internal validity, and now I can establish definitively if being male or being female causes you to be more aggressive. Everyone with me so far? Questions up to now? Perfect. All right, so let's now move in to point number 4, characteristic number 4. Give me a second, guys. Let me drink some water. Research methods gets me going. Burn a lot of calories sitting here. That's what happens. All right. So number 4, the nature of participation. Now, whenever it is that we want to have participants come in and participate in our research studies, we have a couple of different options. The first option that we have is that we allow participants to only be in one group of my study, and only in one group. So in other words, these participants come in, they can only receive therapy number 1, and that's it. They can't receive therapy number 2. Why? Because I don't want them to be able to experience therapy number 2. Maybe they don't meet the criteria, or maybe I don't want the effects of therapy 1 carrying over to the effects of therapy number 2. But rather, what do I want? These people come in, they're only in group 1, and that is it. Everyone good? We call that a between groups research design. A between groups research design. So in other words, people in group 1 are different from people in group 2. Think of it also as something like with male and female. This is a between groups design. People in group 1 in my male group are different from the people in my female group. They're completely different individuals. So here, this solves the issue of having these pre-existing group differences in the sense of, well, they already come in being different naturally because they're male and they're being female. So here, well, that's fine. You just put them in group 1 and you put them in group 2 and there's not a problem. Now, one of the possible issues that I may potentially have is that they may come with other potential factors. So let's say that just by chance, for whatever the case may be, the group of male people that you get are people who only completed a high school degree. And the people that you get who are female all have PhDs. You now have a naturally occurring group difference that you are not accounting for. Everyone with me so far? That becomes a problem. So here, they're male and they're female, they're mutually exclusive groups, not a problem. But now the people that you have within the groups are the actual problem themselves because they're not equivalent. So what do you need to do? You either need to bring the males up to PhDs and all have PhDs, or they all have to have high school diplomas and that's it. They have to be equivalent because if not, you're introducing error variance. Everyone with me? Perfect. Any questions, concerns at this point? Perfect. All right. So now, what do we do then to solve that problem? Well, one of the ways that we can solve this is by having the same people be in multiple groups. So in other words, what are we going to do? We're going to give people in group therapy number 1 the same group therapy in number 2, but they're going to be the same individuals. Different therapies, but they're going to be the exact same individuals. So here, after therapy in number 1, we score their assessments and they get a 90. Now we give them therapy number 2. We look at their assessment. Now it's 150. Now, based on their scores, I can make a conclusion as to what effect my therapy techniques are having on their participation. Does that make sense? Now, one of the problems that I have by doing this is I have the problem of having what we call practice effects and carryover effects. Practice and carryover effects. What does it mean to have a practice effect? Just like the name sounds, well, people practice doing the task over and over and over again. They naturally become better at taking that task. It's like riding a bicycle. The first time you rode it, not that great. Second time, a little bit better, and so on and so forth. The same thing happens if we give you the same assessment every single time. The first time, you score X. The second time around, you already recognize some of the questions. You probably score a little bit better because now you're ready for those specific questions because you've already seen them before. Now, the second issue that we may encounter with a within groups research design, so again, where we use the same individuals across multiple groups, is that we may encounter what's called a carryover effect. We find this a lot with drugs or with drug research studies, that participants come in and we give them a drug, and now we come in for session number 2, and the drug in session number 1 hasn't completely gone out of their system. So for example, let's say that participant number 1 comes in and we give them 6 beers. Okay, we're going to look at their locomotor movement after consuming alcohol. We give them 6 beers at time 1, okay, for participant 1. So now participant 1 comes back, and time 2, we give them 12 beers because we want to see what the effects of drinking a 6-pack are versus a 12-pack. Now the problem that we have is that participant number 1 came in at 8 a.m. Participant number 1 was sent home and then came back at 10 a.m. on the exact same day. So at time 2, we observed their score having, let's say, 60 mistakes. At time 1, they had 10 mistakes. Is the representation of this 60 really for 12 beers, or is it for 18 beers? It's really for 18 beers. And why? Because 2-hour gap between when you drank 6 beers to 12 beers, we all know that. That's not enough time for it to get out of your system. You're not good to go. So here, this 60 is not a representation of 12, but rather it's a representation of 18 beers. Everyone with me so far? So what should you do? Participant number 1 comes in at 8 a.m. on a Monday. Participant number 1 goes home. They wait 48 hours. They come back on Wednesday at 8 or 10 a.m. It doesn't really matter. And now we give them the 12 beers. We waited 48 hours. That should have been plenty of time for them to get that beer out of their system and to now consume 12 beers and only have that 12 beer score. And now we find that at 48 hours later, their score is really a 35, not a 60. Everyone with me so far? So even though we do see the scores increase, now we have a clearer, more accurate representation of what the effect is because we allowed that drug to get out of their system, thus eliminating that carryover effect. Now, the last issue that we encounter associated with the within groups research design is that we can suffer from what's called attrition. Attrition means that people just do not come back for multiple sessions. This happens very, very frequently. Generally, we say that if a participant comes in for one session and then comes back for another session, you're about to lose about 20 to 30% of participants for each additional session that you have after the first one. So in other words, you have 100 participants. For session number 2, you tend to lose between 20 to 30 people the second time around, unless you have a really good recruitment strategy. And why? Well, because participants just decide not to come back. Some participants say, I already went and participated in that study. I already did time number 1. I don't have time to go back and do session number 2. I'm busy. I signed up for 1, but I can't do number 2. Sorry. Or participants forget, or participants get busy doing something else, or participants move, or participants die, or whatever the case may be, and we lose participants. So every single session that we include and that we add to our data collection process, we have less and less and less participants every single time. This is why it's generally important for us to, when we have data collection, we gather as many data points as possible. The larger the number of participants, the better, because if you have multiple sessions, you're always going to lose people. Questions, concerns at this time? Everyone good? Perfect. Let's now look at our last characteristic. So our last characteristic is the issue with what's the study's purpose. So what is the whole point of us actually doing this research study? And there really is two different purposes to doing research study. The issues related to basic research and the issues related to doing applied research. Now with basic research, this means that all that I'm trying to do is I'm trying to further and extend the understanding associated with the specific phenomenon. In other words, I'm not trying to implement my findings into the real world in any capacity. It's not going to be used for therapy. It's not going to be used to help employees become more satisfied. It's not going to help people learn a language faster. It's not going to help people become more motivated or less aggressive out in the real world. That's not the point. All I'm doing as a researcher is I'm extending our understanding of that phenomenon. In other words, I find that men are more aggressive than women in the lab. All I'm doing is I'm adding to the body of knowledge. We didn't know that men were more aggressive than women in this particular situation. I did that research study. That's what I found. That's what I'm publishing. That's it. If other people want to take my work and apply it to some real world situation, that's fine. But for my purpose, this is all I want to do. Everyone with me so far? Generally, basic research is done in the lab. Since it's done in the lab, again, it's generally going to have a higher internal validity and less external validity since we're doing it in the lab. And again, since the purpose is not really to apply it to a real world setting, we're not going to do it in the field. We're not going to have any purpose for applying it to the real world. So it generally tends to have less external validity in those situations. Most research that you guys read that's published that comes from universities is generally basic research. We're just trying to further our understanding of that knowledge. Now, if you don't want to just further our understanding of the knowledge and you actually want to take your work and use it to solve some real world problem or some real world issue, this is where applied research comes into play. So the purpose of applied research is to take what we've learned in the lab and apply it to the real world. Use it now to solve some real world problem. So in other words, we find that men are more aggressive than women in the lab. And we find that men out in the real world tend to have more, engage in more spousal abuse towards their female partners than the reverse. So what do? We try to implement some technique, full knowing that men tend to be more aggressive, and try to educate men so that way they learn that it's not appropriate to have physical violence towards their partners, X, Y, and Z, to solve some real world problem. Everyone with me so far? Questions up to now? Everyone good? Now, contrary to a basic research design, since applied research is done out in the field, out in the real world, generally we have less internal validity since it's done out there in the real world, and we have a higher degree of external validity where we have the situation where we say, hey, our results really do translate to a real world situation, but yet there are other possible factors that might contribute to error variance. So, just to quickly summarize kind of what it is that we've talked about in these all these points, the idea of a research design is really there to help you answer your research question and test your research hypothesis. The purpose of a research design is not to be the purpose of your research study, but rather its purpose is to help you answer your question through the testing of your hypothesis. And now realize that you may have multiple research questions within your research study. There may be different questions and different hypotheses, and you may use different techniques and different designs within your research studies. So if for one research question, you may use qualitative data. For another research question, you may use quantitative data. For one question, you may do it out in the lab. For another research study, you may do it out in the field, whatever the case may be. So don't always be tied down to one single type of design. And also the moral of the story is Bounty is much more absorbing than any other one. Questions, concerns at this point? I'm going to go ahead and stop the point for us. The remainder of our lecture will be online for you guys a little bit later on. So just come back and check on it a little while later. Just so that way you guys can make sure that you can view that part of the lecture. And I will also be posting up this part of the lecture on YouTube as well. And I'll put the link up there for you so that way you're able to view this part of the lecture in case you want to go back to anything that you would like. Questions, concerns at this time, guys? All right. So then we're done for today, guys. I hope you have a good rest of your afternoon. Make sure to check on Blackboard for the weekly information sheet to see what it is that we have to do for Thursday. And one thing I will tell you, on Thursday, there is that lecture posted on Blackboard also. It is a video associated with how to begin your literature review and how to find research articles. On Tuesday of next week, we're going to spend a little bit of time talking about that. But I do recommend that you watch those videos prior to coming to class on Tuesday, okay? All right. Have a good rest of your day. I'm sorry for the little bit of technical glitches that we had. Hopefully we'll get this solved for next week. Bye-bye, guys.